Okay, I just want to show you, there's one problem in the homework where the answer comes out a little funky, so I want to do one like that with you. So this is the problem we're going to do. So write that down if you haven't already. There's a couple layers of funkiness to this problem. You guys, considering that we want to kill variables, do you notice something that seems nice about this problem? Yeah, two birds, one stone.
Why can't equal 5 and -3?
Say again?
Why can't equal 5 and -3?
Yeah, thankfully it doesn't say that, does it? How do I kill x and z? What do I do? How do I kill x and z? I have to do what with these? Add equation 1 to equation 2. So you get 2y equals 2. I like it. So be careful, just because you touch the equations doesn't make these die. You actually have to add the equations together to make them die. And you make this third new equation. So y is 1. Now on one level you're like, oh my gosh, I'm so lucky. But then you start to think, what do I do next? And then you're like, oh, okay, am I lucky? What do you do next? Yeah, good. I love it. So this is so weird to me that I like that it came to you pretty quickly. I know y is 1, so let me just replace y with 1 everywhere. Right? I know y is 1. Good. So stay with me now. So what's equation number 1 become?
X plus 1.
Yeah, and then I can subtract 1. So I get x plus z equals 4. Is that cool? If I put a 1 in for y, subtract 1. Put a 1 in for y. Because I know y is 1. And then subtract 1. So I get negative x minus z equals negative 4. So you guys might realize that's not really telling me too much. And then here, when I put a y equals 1 in here, subtract 1, I get 2x plus 2z equals 8. I really want to make sure. And we know y is 1. So I put 1 in for all the y's. Subtract the 1s that get all the numbers together on the other side like we should want to. And then that's where I end up. Does anybody notice something about those three equations?
The same.
They're all the same. Divide by 2, you get x plus z equals 4. Same as that one. Divide by negative 1, you get x plus z equals 4. Same as that one. Same. So if between two of them you try to kill x, you're going to get 0 equals 0, won't you? And what does that mean when you get... Do you guys see that? If I kill the x between these two, when I get 0, 0, 0. I get 0 equals 0, which means what? Beautifully said. Not all real numbers, because the answer here are points. There are an infinite number of answers. I'm going to let all that sink in. We know that's what that means when we get 0 equals 0. Yes, sir?
Because you can add, divide, multiply anything into either side.
That's kind of one way to look at it. But what this is really saying is these all define the same line, right? So one way that three planes can come together. If I say Rolodex, do you guys know what that is from back in the ancient days?
Yes.
So I could have three planes that come together. I don't know if I can do it up here, just me by myself. Can three planes come together at a line, right? That's great. Like a Rolodex, three planes. I can't think about how to do it. Screw it. I need one more person to help. So I can have three planes come together at a single line. If I had a third piece of paper up there, they can come together that line right there. Is that cool?
Yeah.
I like it. So therefore, there's an infinite number of answers. It's not enough to just stop and say, there's an infinite number of answers. I want to know what they are. I don't want you to list them. So let me see if you guys... Let's see what's happening. Solve this for z, for example. Z equals what? Solve it for z.
X minus
4 minus x. And what was y? 1. And what's x? X. So there's an infinite number of answers. So you can't tell me the answer is 217. No, the answer is any x you want. Y has to be 1. And then z has to be 4 minus x. Any point that looks like that is an answer to this. So let's say, what if x is 3? What point would that be? 3, 1, 1. So if you plug 3 plus 1 is 5, right? Negative 3 plus 1 is negative 2. Minus 1 is negative, and so forth. I mean, anything you build, so what, if x is 5, 5, 1, negative 1. If x is 112, 1, negative 108. Any x you pick, you're going to get another point that works. So that's what it means. You don't just stop here and say infinite number of solutions. You have to solve for a letter. So whatever x is, z has to be 4 minus that. So this describes the infinite number of answers. They all have to look like this. So could the point 7, 2, 6 be an answer? Here. What's the middle number have to be?
1.
Okay, good. So it's got to be something 1 something. I like it. So if x is 10, 10, 1, negative 6. That would work in all of these equations. Okay, so you have one problem like that. That's right. And they have several examples in the thing. But I really want you to understand, if there is an infinite number of solutions, they probably can be defined somehow. Like, if it's that line where they meet, there must be some equation for that line. This is the equation for the line. To be honest, that's what that really is. It doesn't look like one, does it? If I pointed this and said this equation of line, without any explanation, you can go, no it ain't. Thank you very much for playing, Jeff. Right, but it is. That's the equation of the points on a line. What line? The line where all three planes meet. So there's an infinite number of points on any line. Is that true? Mm-hmm. Yes. But they are defined in a specific way. This is the way that these points are defined. Okay. Whew. So there's just one problem like that. I just wanted to try it out. There's examples in the book. Okay. Okay. So I was hoping a decent number of people got the synthetic division problem. I made it bonus just because. I was hoping to give everybody a free bonus because I think most of us are pretty decent with synthetic division. The trick with that bonus one was you had to realize you had to put a 0 in, right? The one on the test? Okay, the bonus one? What was the whole idea of synthetic division? What was the main idea behind it?
Simplify.
Yes. So, if I have this problem here, long division would leave all the what's in there, but synthetic division would take out all the what's. Variables. So synthetic only focuses on the coefficients, right? On the actual numbers. As long as this is in order, and anybody I'm missing, I put a 0 in there, then I can forget about the x's. I can just focus on the numbers, and then bring the x's back in at the end. So the main reason that this process sucks is because I keep having to write x, y, and z, and x, and n. But every step I take, what makes me make a decision is what the coefficients are. If the coefficient of this x is 2, and this is just x, I'm going to multiply that by negative 2. What told me to do that? The coefficients told me to do that. Not the x. I could have put an a there, and I would have done the same damn thing, right? So, if I said, solve this, what would you do first? Well, how would you solve that? Multiply first one by 2. I love it. So how do you solve this? gather. Let me make the same damn thing. There you go. Good job. Method to your madness. What would you do first here? Look. Do you guys realize that's the same equations as that, right? They're the same thing. I just chose to call the unknown a different thing. Ooh. We call variables, the further you get in math, the more you call them dummy variables. What do you use dummies for when you're testing cars? You use them in place of people, right? So that only the dummies get hurt.
Expendable.
Exactly. So who cares if you use a blue dummy versus a red dummy? Who cares if I use an X instead of an A? It's just represented a thing I don't know. So that's what synthetic division does. Who cares if I call these X's or Y's or Z's? As long as they're in the right order, I should be able to just look at the numbers. So we're going to do a similar thing. I should have left that last one up there, but with matrices, with systems of equations, we're going to use something called matrices, right? So we're going to create a matrix. Cool. Not the there is no spoon thing, but you know. So what was that very first problem? Let's see. Well, I'll use this one here. I'll use this one because we know what the answer is for this one. Alright, so this is the same problem that's on the section 9 one side, and now we're transitioning into section 9 2. So maybe don't pay too much attention to that side yet. So we're not going to do it the old way here, the section 9 one way, but what would be the first thing I would do here maybe? What letter can we kill easy?
X.
Yeah, you would do what first? Yeah, because these coefficients are 1 and -1, and when you add 1 and -1, you make 0. So I'd have 0 x's in that new equation. So if I focus all my attention on just the coefficients, then what do I want to make happen everywhere? I want to make zeros show up. Because what does a 0 mean? It means I have none of those variables. I've killed that variable. And is that the whole purpose? Is that what we do? We kill. Because there's too many of them. We have to keep the variable population in check. Right? Unleash the hunters out there. Okay. So here's what it looks like. It sort of feels a little bit like synthetic division in a certain way. So when I write this as a matrix, I first make sure that everything is, if I had some X's and Z's and Y's, that's no good. I need this to be the X column, the Y column, the Z column. Then I can just look at the numbers and not care about the variables anymore. So now I can write this matrix would be, what are the coefficients?
1, 7.
That's a Z. 2. 3, 1, -2, 9, -1, 2, 5, 6. And the thing I'm not going to be able to stop myself from doing is that. I don't think the book does that. Oh yeah, it does. Yay! Sorry. I always forget. Yeah, I think the old book we used before this didn't. This line separates the variable part from the numbers part. This line is like the equals. Do you see that? Alright, good. Alright, let me talk about this matrix just for a minute. Does everybody see where it came from? Yeah. It's not that big of a step from here to there. And why is that better? Because now I don't have to write X and Z and all that crap over and over. And to be honest, it's going to take a little bit of getting used to, but it's much more efficient. The process we used in section 9.1 to solve this would get incredibly much worse if I added one more variable on here. Can you imagine that? And then I'd have to add another equation, wouldn't I? Because how many unknowns do I have now? 4 unknowns. So then I need one more equation. You have to kill a letter 3 times. And then from those 3, kill a letter twice. Oh, screw that shit, Jeff. I'll never do that to you. So what this does, the way that you solve this, it's just about the same length of time to do. Even if I add a whole other variable and equation in, it's going to take about the same amount of time. And it's much easier to program a computer to do this than it is to do this. All right. So, the reason I just said what I did earlier, the first thing we would do is add these equations together, right? Because then it would make a 0. So what you're really focused on when you're doing a matrix then is you want to make zeros show up. If I make a 0 show up there and a 0 show up there, then I've killed those x's, haven't I?
Yeah.
And isn't that related to what I said we do when we do it by hand? The whole algebraic way to do it by hand here? Alright, so let me put up here. Here's our goal. Our goal is to make this look like this. Number, number, number. Alright, somebody help me out. So this, if I read this as an equation, what equation this would be? This would be x minus y plus z equals 2. So what equation is this? X equals number. So if I can make this look like this, I can read the answer off in that last column. So it's very interesting. It's the same exact reasoning, but it refocuses our attention. It makes it easier to kind of think about what to do next. I want to find a 1 and then make everything else 0. So I could actually start here if I wanted to. I could use that one and kill these. So that's the idea. 1s are nice because I can make them become anything I want to and kill something else. 0s are the real goal. I want to make 0s because that's killing my variables. Right? Okay, that's the background story. Now let's get into the actual nuts and bolts. How the hell is this shit going to happen, Jeff? I don't know. All right. So now you kind of refocus your attention. I'm going to talk about these as rows. But everything I can do with equations, I can do with rows because a row is a freaking equation, right? So I could double this row, triple this row, whatever. So the first thing I'm going to do, though, how can I get closer to this goal? Looking at the first column first, I need a 0 here. Can I make a 0 show up here? If I do what? Take row 1, add it to row 2. If I add row 1 and row 2, won't there be a 0 here?
Yeah.
Okay. So it's just like adding this equation to this equation. It's the exact same thing. So I know some of you guys are out there going, well, then why the hell would I just do this, Jeff? And I'm hoping at least some of you guys are like, well, this is going to be a lot quicker once I get to understand how the hell it works.
I was wondering, I know what you want, X, Y, and Z. But looking at the number, do we want all the left to be a certain number, or do we want all the left to be 0?
You mean here?
No.
No.
We have the numbers on the right, but on the left side.
So I want to end up here, because then I'll know X equals this, Y equals this, and Z equals this.
Okay,
So now I start to look at it column by column. I want to make zeros there and there.
Okay, so then if we were to do the zeros and get the second one and the first one on the far left 0, then that means the top is 1 and on the far side is 2.
Let's start doing it. I'm not exactly sure what your question is, but let's start doing some steps and see if we can address it. So the very first thing I would do, and this is what you should write for 2 reasons. So you remember what the hell you did, and the person grading your stuff knows what the hell you're doing. Don't just have numbers come out of nowhere. Tell me somehow, and this is the way I write it, but you can figure out some way. Row 1 plus row 3. Now, where am I going to put the answer? These 3 equations suck because they all have 3 unknowns. This new equation I'm going to make only has 2, so it's better. So I'm going to overwrite one of these. So this is the organizational part of this. It's easier to organize. Where am I going to put the answer? Where do I want the 0 to show up? Which row? Row 3. So I'm going to put the answer in row 3. So when I add row 1 to row 3, what do I get? 1 minus 1? 0. Negative 1 plus 2? 1. 1 plus 5? 6. 2 plus 6? 8. And then everything else stays the same.
Yeah.
Wait. Watch. What would you do here? When you add these 2, you would add 1 to 3, wouldn't you? What do you get when you add 1 and 3? 0.
1.
You get y, right?
Yeah.
Plus 6z equals 8. So wouldn't it be 0 x's, 0 x's, 1 y, 1 y, 6z, 6z, 8, 8.
Got it.
So that is what the matrix is doing. It makes us shift our perspective a little bit. Now instead of killing variables, I'm trying to make zeros. But that's the same thing, because when I make zeros, I have killed that variable. So when I add these equations together, what am I actually adding together? The coefficients. So matrices say, well then just look at the freaking numbers. That's all you care about, really. Yes, sir.
Go how you got the numbers one more time. No, that's on the bottom one. Yeah.
Yeah. If I take row 1, which is equation 1, and I add it to row 3, which is equation 3, these will cancel. Meaning that x goes away. So 1 plus negative 1 is 0. Negative 1 plus 2 is 1. 1 plus 5 is 6. 2 plus 6 is 8. And the other 2 I left alone.
Okay.
So as you get used to this, you only change one row at a time. Now, this really becomes efficient when you start to realize I could change more than that at a time, and then I don't have to rewrite this freaking matrix over and over and over again. But that, as you get more used to it, you can start to do that.
And you only want 1 0 and the rest?
So you want
Or it
to.
could be multiple.
So I know this is my goal. The way, especially when you're getting used to this, the way to make sure that what really sucks is when you lose a 0. When you add something to something else and the 0 you had goes away. You don't want to lose zeros. So the way to make sure that you're not stepping on your own toes is to make the first column look the way it's supposed to. Then make the next column look the way it's supposed to. Because now, if I add these rows together, those zeros won't screw with each other. I don't know if you guys... Well, again, we haven't done enough of this to know what the hell I'm talking about yet. Alright. So why does that first column not look right? For my goal?
Because you have a 3.
I got a 3 there. I don't want a stupid 3 there. Alright. So let me see if you guys can get... Now again, this kind of really, really, really shows you every little thing. I put in the middle, everything. This handout. I'm going to desperately try to get you guys to realize... let me see if this works. How would I kill that 3? What do I have to do? And it's really, you can think of how do I kill that? I would multiply the first one by
-3.
-3. I love it. So I would do -3 row 1 plus row 2. Right? Isn't that what we're doing? Multiply this one by -3. Add it to this one. Well, what's this one? This is row 2. And where do you want to put the answer? In row 2. And again, if you've never seen matrices before, how many of you have never seen matrices until this today? Okay, good. That's not good, but it's good. It's fine. Give yourself a little break. Let it sink in. If this is the first time you're seeing it, it's going to be a real... It's like learning how to drive manual if you only know how to drive automatic. You don't know? I'm sorry. That's a bad example. I don't know. It takes a little bit of getting used to, and you have to refocus your attention. Now, what I hate doing is rewriting the matrix more times than I have to. What's the only reason I got to multiply this by -3? Is so that I can kill... Now, what do I want here? So then I would divide this by -3 and bring it back to where it is. So I'm not going to really multiply by -3. I'm just going to put next to it for myself. What is 1 times -3? What is -1 times -3? I'm just going to put the numbers next to it, what it would become if I multiplied it by -3. So what is this related to? Again, just to show you the analogy, how would you kill this 3? You would multiply the first equation by -3. So it would be -3x plus 3y, so forth. So that's, right? There's the 3y. Multiply by -3. So I'm going to leave this row as it is, and the next iteration, I'm going to leave it as 1, -1, 1, 2. But now I'm going to add these together. Because what do I want? How do I kill this 3? Take -3 row 1 plus row 2, right? I really want that to... Do you see why? I'm not going to actually write these in the matrix. And then I have to write it again with a 1 there. Don't do that to yourself. This is what it would be. Use it, and then get rid of it. I don't need it. So -3 plus 3? 0. 3 plus 1?
4.
4.
-5.
-5.
Three.
3. And then the third row I leave alone. Okay. So that's equivalent to, and again, you don't have to write all this, but I just want to show you. What would this look like? It would look like this. -3 times 1. And then the second one. And then when I add these, I would get 0, 4y, minus 5z equals 3. 4, -5, 3. 4, -5, 3. Continue to let it sink in.
So how many of these matrices will we have by the time we solve this? Which is still-
Well, how many times do I have to rewrite it? It
Yeah.
depends on how many shortcuts you know and can take. Now again, remember all the writing this took, right? And I'm eliminating all the x, y's, and z's. And the real power of this, with 3 letters, they're about the same amount of work, to be completely honest. But the matrix kicks this guy's ass the minute you add any more letters on top. In the real world, how many unknowns are there in any situation? A lot. So in the real world, matrices are used everywhere. Anybody ever use Excel? Excel, anybody ever heard of Excel? All right. It's not, I'm not trying to sell you Amway. What's Excel? Excel 2017. No. Amway, anybody ever heard of Amway? Okay, good. Leave it that way. Sorry. Excel is built off of matrices. I mean, it's almost too obvious. It's got columns, it's got rows, and a lot of the math it does is related to some stuff we're doing. Now, there's a lot more you can do with matrices than what we're doing. Matrices exist for a lot more reasons than this. They exist by themselves. This is one use of matrices. Okay. Yes, sir.
So now we add first and third one, and we start working on the rest.
I love it. I love it. So now, now I'm going to start to get you guys to realize, please, dear God, do not divide by 4. Why would I divide by 4 maybe?
To get it to 1.
To get it to 1. The 1s are not as important as the 0s. 0s are the most important because then that means I kill that letter. Why? I don't want to divide by 4 because then I make a bunch of freaking fractions. Screw that shit. So, is my first column look the way it's supposed to?
Yeah.
Yes. So now I move to the second column. Well, to be honest, it doesn't matter. We could do the third column if you wanted to. Let's go ahead and do it in order. So like Nathan said, what can you kill? Where do you want a 0? You want a 0 to show up here, right? Mm-hmm. So how can you make this become 0? Add these together. So some of you guys are starting to realize the matrix just makes it an easier thing to think about. I don't want to all right, make a 0 there. How? Any way you can. Yes?
When we add them together, can we just make them both 0 and just knock out 2 birds, 1 stone?
No, because then you would put the same answer twice, and that's not good. I don't want to have the same equation twice. Do you see? Because that's what would happen. You would write the same equation twice, and that's not good. Then it's like infinite number solutions again. So I can't write the same equation twice in a matrix. It's not good. I don't know how to say it. All right. Let's see. How can I make this continue on? Yeah. All right. So just some of you guys might realize I could have done both of these 0s all at once. I didn't have to write the matrix as many times as I did. So I agree with you. How many freaking times I got to write this damn thing? Well, that's good motivation for me to figure out some shortcuts, right? Right, I'm going to show you more than the chef because this is the first time we're seeing this thing. So now I'm going to do what? Add
0.
Add row 1
So
to row 3 and put the answer in
row 1.
row 1. And look, that 0 won't screw with that 1. Do you see? That's why if you do the first column, these 0s won't screw with that 1. That's kind of like why we do it in this order. I like it. Put the answer in row 1. So 0 plus 1 is 1. 1 minus 1, 0. 6 plus 1, 7. 8 plus 2, 10. Let me see if we can handle more than one thing. Yes, sir.
Why don't you multiply by 3 since then you have to, like, before you multiply the first row by 3, you put it on the top.
Here?
Yeah.
Why did I do this? Because there was a 3 here.
Yeah, but why didn't you, like, consider that when you were doing that step that you just did right now?
Well, what am I trying to kill? I'm trying to kill that. And that kills that. If that was in -4, I would have had to, well, that would have, if that was in -3, I would have had to multiply this by 3, wouldn't I? Because then it would become 3 minus 3 is 0. But these already kill each other. The only reason I did this is because that was a 3. 1 and 3 don't kill each other. -3 and 3, oh shit, I gotta multiply this by -3.
So what do you do with the -3?
The only reason I multiplied this row by -3 was to kill this. Then I can divide this row by -3 and it comes back to the same thing again. That's why I do it this way. I only put what it would be next to it. I don't have to rewrite the matrix all over again. Does that make sense? All right, good. There's a lot of little bits and pieces to this that just have to kind of sink in a little bit. And the more you understand it, the less work there is to do with this. All right? All right, so let me try to show you another shortcut. How am I going to kill that 4 here?
Multiply the third row by negative.
Yeah, multiply this by -1. Now, some of you guys might worry that if I put a 0 there,